Hi children, good morning. In the previous class, we discussed consecutive numbers and highest power of t contained in n factorial. These things we discussed. Small problem we discussed today, then I will continue my class. Now, find the number of zeros in 100 factorial. Find number of zeros in 100 factorial. Here, one thing you have to observe. Here the generator of 0, first you need to find the generator of 0. Okay, any number is multiplied by 10, you will get the 0. For getting 10, we want 2 and 5. Mean, first we need to find the highest power of 2 contained in 100 factorial as well highest power of 5 contained in 100 factorial. Now highest power of 2 contained in 100 factorial means 100 by 2 plus 100 by 4 plus 100 by 8 plus 100 by 16 plus 100 by 32 plus 100 by 62. Here 50 plus 25 plus 12, 12.5 means 12 only. Here 16 means 6, 32 means 3, 64 means 1. So here yesterday we did this one. 97 means highest power of 2 is 97. Next, highest power of 5 contained in 100 factorial. That is 100 by 5, 100 by 25, 100 by 125. 100 by 5 means 20, 100 by 25 means 4, here 0, here we will get 24. Mean 5 power 24. For getting zeros, here we want the intersection part. Okay, here 97 elements are given, here 24 elements are given. These 24 are common to 97. That's why you will get 24 zeros. 100 factorial ends with 24 zeros. In this way you can find. Okay. Number of zeros in the sense highest power of 10 contained in n factorial indirectly. Highest power of 10 in n factorial they are asking. Highest power of 10. So for getting 10, 10 is a composite, that's why we need to arrange in terms of product of primes. 2 into 5. So highest power of 2, highest power of 5. Okay, here 5's are less than 2. For getting zeros, we want 2 power 24 into 5 power 24. Out of 97 2's, we require only 24 because a pair of 2 and 5 only gives the 0. That's why. Okay, this is the formula for finding a number of zeros ends in n factorial. Okay, next. New one, congruences. Congruences. This congruence is completely different from This congruence is completely different from triangular congruences. Mean plane geometrical congruence and these are completely different. The concept of congruence was first introduced by German mathematician Carl Friedrich Gauss. He is a German mathematician. Carl Friedrich Gauss. This congruence is a refined statement of divisibility. This congruence is a refined statement of divisibility. Okay, this provides us with an algebraic machinery this provides us with algebraic machinery for the study of divisibility properties. For the study of divisibility properties of integers. For the study of divisibility property of integers. Congruences. This congruences was first introduced by Carl Friedrich Gauss, is a German mathematician. It's a refined statement of divisibility. It's a refined statement of divisibility. This provides us with an algebraic machinery for the study of divisibility properties of integers. Okay, next. Congruences definition. Here, let M be a fixed integer. A is congruent to B to the mod M, which means M divides A minus B. Okay, the definition of congruence is this one. This can be read as A is congruent to B to the mod M. A is congruent to B to the mod M. Okay, here M is a fixed integer. Here A, B are also integers. A, B are also integers. Okay, A congruent to B to the mod M, which means M divides A minus B. M divides A minus B. For example, 67 is congruent to 2 to the mod 13. Is it correct or not? Yes, because 67 minus 2 equal to 65 is divided by 13. Means we can say that 13 divides 65. 13 divides 65. Means 67 minus 2. Mean 13 divides 67 minus 2. That means 13 divides 65. 13 divides 65. Another example. 6 congruent to 1 to the mod 5. Mean 5 divides 6 minus 1. 5 divides 6 minus 1 because 5 is a factor of 5. Here 13 is a factor of 16. A divides B mean A is a factor while B is a multiple. B divides A mean B is a factor, A is a multiple. Don't confuse. Next. Here 5 is congruent to 1 to the mod 2. Mean here 2 divides 5 minus 1. Mean 2 divides 4. 2 divides 4. Okay, like that we can write the refinery statements. Refinery statement. Once observation, this one also true. Here 5 is congruent to 5 to the mod 6 because 6 divides 5 minus 5 means 6 is a factor of 0. Every number is a factor of 0. Okay. Otherwise, we can write it as here 5 congruent to minus 1 to the mod 6 because 6 divides 5 minus of minus 1. So 6 divides 6. Okay, here it's a refined statement of divisibility. First one I said it's a refined statement of divisibility. The definition of congruence is A is congruent to B to the mod M. Here M comma A comma B are integers. Here M is fixed. M is fixed. So here A is congruent to B to the mod M mean M divides A minus B. M divides A minus B. So these are the examples. If 67 divided by 13, 2 is the remainder. Like that also we can say. Means 67 is congruent to 2 to the mod 13 mean if 67 divided by 13, you will get 2 as the remainder. Here 6 divided by 5, 1 is the remainder. Here 5 divided by 2, 1 is the remainder. Mean 2 divides 5 minus 1. 5 divides 6 minus 1. Okay. Here the important one. 5 congruent to minus 1 to the mod 6. Means 6 divides 5 minus of minus 1. Okay. Likewise 7 congruent to minus 3 to the mod 10. Mean 10 divides 7 minus of minus 3. Mean 10 divides 10. 10 divides 10. These are the refined statements of divisibility. Now, basic properties of congruence. Basic properties. Basic properties of congruences. Here, the important thing is if m greater than 0, m greater than 0 is fixed and a comma b comma c comma d are integers. Okay, m greater than 0 means positive and it is a fixed. Here a, b, c, d are the given integers. The first one a congruent to a to the mod m. How can we say? Mean here m divides a minus a. Mean m divides 0. Mean m is a factor of 0. That's why you can write it as a congruent to A to the mod M. Next, second one. If A congruent to B to the mod M, then B congruent to A to the mod M. Okay, here A congruent to B to the mod M means M divides A minus B. Now, if you take minus common, then A minus B turns into B minus A. So, M divides B minus A means B congruent to A to the mod M. Important. Okay, here A congruent to B to the mod M. Then we need to prove B is also congruent to A to the mod M. So here A is congruent to B means M divides A minus B. Here if you take minus common, A minus B becomes B minus A. Okay, 2 is a factor of 4 means 2 is a factor of minus 4 also. 2 is a factor of 4 means 2 is also a factor of minus 4. Okay, these are the first two properties. First one, A congruent to A means 5 congruent to 5. Here 2 congruent to 5 means 5 also congruent to 2. To the same mod. To the same mod. Next. Third one. If A congruent to B to the mod M and B congruent to C to the mod M, then A congruent to C to the mod M. A congruent to B congruent to C means A is also congruent to C to the mod M. We need to prove this one. Okay, for proving this condition, first proof. What is given? A is congruent to B to the mod M, which means M divides A minus B. M divides A minus B. Let it be first equation. Next, B congruent to C to the mod M there. So here we can say M divides B minus C. That is second one. Okay, if you add first and second, so M divides A minus B plus B minus C. That divides M. Here A minus B plus B cancel. M divides A minus C. Here M divides A minus C means A is congruent to C to the mod M. Once observe. I will show that one. Next, what is given? A is congruent to B to the mod M. B is congruent to C to the mod M. Then we need to prove A is congruent to C to the mod M. For proving this one, A is congruent to B to the mod M means M divides A minus B. B is congruent to C to the mod M means M divides B minus C. If you add first and second equations, then you will get M divides A minus B plus B minus C. So minus B plus C get cancelled. M divides A minus C. M divides A minus C means A is congruent to C to the mod M. These are the refined statements. Listen carefully. Next, if A congruent to B to the mod M and C congruent to D to the mod M. Then first one, A plus C congruent to B plus D to the mod M. Second one, A into C to the congruent to B into D to the mod M. My important one. For proving conditions, we should use these conditions only. Okay, for problems. Proof for this one. Proof. Here A congruent to B to the mod M again. That means M divides A minus B. That's the first one. Next, C to D. C is congruent to D to the mod M again, which means M divides A minus B. M divides A minus B, that is second. On adding 1 and 2, M divides A minus B plus C minus B. So, M divides A plus C. If you take minus common, B plus D. So M divides A plus C minus B plus D mean here A plus C is congruent to B plus D to the mod M by using this condition. Here they gave A is congruent to B. Written as M divides A minus B. Now we got M divides something minus something. A plus C minus B plus D. So A plus C is congruent to B plus D. To the mod M. Here these are the refined statements. These are the refined statements. My most important one. My first part we proved A plus C congruent to B plus D to the mod M. AC, we need to do these two conditions. First condition A plus C to B plus D. If A to B to the mod M, C to D to the mod M later. Okay. First proof. Right. Next. Next, need to prove AC to B. So for proving this one, first of all, here A congruent to B to the mod M mean again this one. By using first one, A minus B equal to multiple of M. So that implies A equal to B plus multiple of M. Next, C minus D is congruent to multiple of M. So here C equal to D plus multiple of M. Okay. M divides A minus B. Mean M divides A minus B mean M is a factor of A minus B. Factor means A minus B equal to multiple of M. Here C minus D equal to multiple of M because M divides A minus D. Here M divides A minus B. M divides A minus B. Here m divides a minus b. I wrote that statement only, don't confuse here. Okay, here m divides a minus b mean a minus b equal to multiple of m. C minus b equal to multiple of m. I changed this one. Minus b turns into plus b. Minus b turns into plus b. Now we got two equations. First one and second one. If you multiply first and second equations, here a into c equal to b plus and b plus multiple of m. Here k1, k2 are any integers. Okay, for multiple side. Now AC equal. Here b into d, bd plus b into mk2 plus mk1 into d plus m into m square k1 k. Now AC equal to bd plus here also m, mean m common, here bk2 plus bk1 plus mk1k. Here AC equal to bd plus multiple of m. Here b means this one. Multiple of m means we wrote m into something like this. M into something. So a equal to b plus m into something mean here AC congruent to BD to the mod m. Okay, AC congruent to BD to the mod m. But don't confuse here. Here they gave A congruent to B. M divides A minus B. Here C congruent to D. M divides C minus D. So here M divides A minus B mean A minus B equal to multiple of M. Here C minus D equal to multiple of M only. Here K1, K2 are n integers. Now we got A equal to B plus multiple of M. C equal to D plus multiple of M. So if you multiply these two things, A into C, AC equal to B plus multiple of M into D plus multiple of M. If you multiply this one, you will get BD plus multiple of M. Multiple of M. So we got the statement like this. Here A congruent to B mean A equal to B plus something. So AC equal to BD plus something mean AC is congruent to BD to the mod M. Like this. Okay. This is the fourth property. Fourth one. Next. Next. Fifth one. Fifth, if A is congruent to B to the mod M, then A plus C is congruent to B plus D, B plus C to the mod M. A is congruent to B, and we can add the same thing both sides of the congruences. There is no change in this given congruence. So here A congruent to B to the mod M they gave, which means M divides A minus B. M divides A minus B. Now I'll add plus C and minus C. Plus C and minus C. Then M divides here I write A plus C minus B minus C. Now M divides A plus C. If you take minus common, then you get B plus C. So here m divides a plus c minus b plus c. When m divides a minus b mean we can write it as a is congruent to b. Here a plus c is congruent to b plus c to the mod m. To the mod m. Okay. See that one. Observe this one. Okay, A is congruent to B to the mod M. Then we need to prove A plus C is congruent to B plus C. Means we can add the same thing to the both side of the congruent. So A plus C is congruent to B plus C. So A is congruent to B means M divides A minus B. If you add plus C and minus C, then we pair it as A plus C and B plus C. So here m divides a plus c minus of b plus c mean a plus c is congruent to b plus c to the mod m. Okay, next. Okay, these 4, 5, 6 properties are important for us. 4, 5, 6 properties are important. Now the next one. Next one. Sixth one. If A is congruent to B to the mod M, then A power K is congruent to B power K to the mod M. Observe here. Here A is congruent to B to the mod M. Means M divides A minus B. So here 2 is a factor of 4 mean 2 is factor of 4 into 2, 2 is factor of 4 into 3, 2 factor of 4 into 4 something. Because 2 is a factor of 4. Likewise, here m is factor of a minus b mean m is factor of a minus b into something also. So that something here a power k minus 1 plus a power k minus 2 into b power 1 plus a power k minus 3 b square and so on at last b power k minus 1. Here a minus b into, for understanding a square plus ab plus b square. So a minus b into a cube plus a square b plus ab square plus b cube. We gives here a cube minus b cube, here a power 4 minus b power 4. So here also we raise the power k minus 1. Mean already we have 1. So m divides a power k minus b power k. So here a power k, m divides a power k minus b power k mean a power k is congruent to b power k to the mod m. Most of the problems in the next class we will do by using the last condition. Okay, here they gave a is congruent to b to the mod m. Then we can prove a power k congruent to b power k to the mod m. For proving this one, a congruent to b means m divides a minus b. So m divides a minus b into something also. That something is a power k minus 1 plus a power k minus 2 into b plus a power k minus b square and so on plus b power k minus 1. Okay, that gives the result as a power k minus b power k. So m divides a power k minus b power k mean by definition of the congruence we can write it as a power k is congruent to b power k to the mod m. To the mod m. One example I will explain for this one. The help of numbers. Tomorrow we will do